All right, so I wanted to show you something. I've basically got kind of this Christmas tree effect going on in the code where you can see all the parsing going on. I did this so you can kind of see it happening live. And if you look over here, you can see that it keeps changing the color codes for this, and it's almost impossible to read if you're actually cycling through this. There's a semicolon. Oh, selecting it kind of got rid of everything. A using statement. Another using statement. What else have we got? A semicolon over there, etc. System dot. It's got all his color tags in here. Anyway, so the formatting ends up parsing the C# live in the executing code, and then I can determine exactly what type of variables types it's using, what type of members it's calling, and I can basically whitelist the entire code project to restrict a user from entering potentially volatile code, such as the ability to format their hard drive, check other applications, and send off passwords, whatever the case might be. All right, so with that in mind, let's go ahead and take a look at how some of this code works. First of all, I'm going to go to the main camera, and you can see over here I've got this simple script called test cs parse. It's got two items that it's asking for. It's asking for the text mesh pro component, so it can put in something with rich text, and then it's got a spot to enter source code, which you just copy and paste into it. All right, so first of all, I'll call this out. We need the Microsoft Code Analysis and Code Analysis C# libraries. If you don't have that or haven't been following along before, there is an article just before this. I'll keep the link in the bottom of the YouTube video as well, in the notes, to go on how to install it. Because basically it is not a clean install to get this into Unity. And to get the steps working and what you need to add, what packages, and then what to delete from what those packages add, it's all covered in another video. Not a video, it's covered in an article. All right, so a couple things. First thing we saw, the source code. This was a source code, just a string that we can paste in there, and it is literally what's in there right now is a copy of this code, this entire class. What is this? It's not that big, and this is 115 lines including white space. All right. Okay, so in here, I have it parsing about 115 lines and goes pretty fast. Now, in order to actually do stuff with this, let's break this down. We got the source code. Then we have, let me skip modifier. I'll come back to that. We also have the text mesh pro, the source code on how it's going to display, the rich text display. And then we have something called kind colors. I'll get to this one as well. But let's move up. What's the first main function we have? We have update, and in update we just check to see if we press space, and if we have, we call parse code 2, because this is test code. Don't look at this code and expect this to represent like an end product for the game. I don't even have a namespace in here called out yet. So architecture, this being a utility, there's all sorts of things that'll be changing in how this gets structured in the end product. Okay, but over here we have our parse code 2. And we're telling it to clear the kind colors because it's remembering what color to use for a kind. Like remember the kinds, the single quote, double quote, field type, variable type, etc. There were over 500 of them. I have it clear it, and this is what gives us the Christmas tree effect. That way I can just press the spacebar again, it parses the whole thing and gives it new colors the next time around. Now here's the first real line of code for this. This is the C# syntax tree. Now its type, you'll find it under Microsoft Codeanalysis.C#. And of course syntax tree you find under it, just not under the C# part. Okay, so we create this tree, and what this does is this is turning our C# source code pretty much into something like an XML document or a JSON document, where it's got nodes that are structured out, items with children that have more children, etc. And each one tells us about the code or the syntax information that we're looking at. All right, so if I want to parse this, there's a lot of different ways I can approach this. Naturally, when I look at this to get it more refined into more of the final product, then I'm going to be looking at performance issues as well. So this is not meant to be performant either, but it works. That's the big thing. All right, so what I'm doing is when I want to get the parsing into effect, I basically find all of the indexes, all of the positions that need to have color formatting information added, and I set those aside. I set those aside and I sort them. So I'm creating this list of modifiers. Now what's a modifier? Let's go up here. Here's a modifier. It is the index of the source code. Where in this? It could be character 0, it could be character 588, whatever it might be. And then what it wants to insert at that position. Okay, so that's all it is. It's just a modifier. It's just a what are we going to modify? We need an index and what we're going to insert there. Okay, so I'll explain this in just a second. So we basically take this list of modifiers. We go through every single node and token in the system, and then we sort them. So whatever we've gotten out of this, we sort them because it doesn't always come back in order. Some things encompass larger areas, which is a section I'm going to have to deal with. One of the types, for instance, is the compilation unit, if I remember what it was called. And that one is basically a copy of the entire source code. So all of the source code ends up having this extra formatter wrapped around it. And I would never end up using that in the first place. So I've got some items to clear out. All right. But anyway, so we sort it so it goes in order from 0 to the end. All right. And then I say we're going to create a string builder because we're going to take all these pieces of strings and attach them. So we definitely want a string builder. If you're doing something more than like 2 or 3 items together in a single line, use a string builder. Okay. So over here we're going through every one of the modifiers that have been sorted, and we're going to append these. We're going to take the source code starting from where we were, which was this previous index starting at 0. And the first time we come to this, it'll probably be 0. The mod index, the index of the modifier where we're going to insert something, that'll be 0, so it'll append nothing. And I would assume String Builder actually deals with that and says, oh, if we're not going to do this, if we're not going to have anything there, then don't even add an item to my array or insert an item to this. Just exit out. All right. So anyway, it grabs a substring of the source code, a piece of it, and then it also appends whatever the modifier wanted us to insert, which in most cases, in the first case, will most likely just be a color tag, starting a color. And then finally, we reset the previous index, so when it comes to the next one in this list, which has already been sorted, we will be able to just grab that next chunk of code. In our case, we were seeing things like the using statement. Let me go to the actual text pro, and here you can see the code. Like I said, how the document itself has an entire section to it. The using statements might have a section to it, but then here's the using keyword itself. Using keyword has this tag. It's color equals hashtag, and then we do the RGBA or RRGGBBAA tag format, and then there's the using keyword. If I look over a little bit farther, we see system. If I look over a little bit farther, we see semicolon. So this code was using system semicolon, and it adds all the color tags. Let's go back into here. And then finally, I take the entire string builder and I set the rich text with it. The UI source.text, that is rich text, so it gets the formatting in there. All those color tags we saw. Now let's see how we put the color tags in. So first of all, when we're creating this list of when we want to fill this list of modifiers, which we're doing over, where do we do this? We've got all the items, we got the list modifiers. Oh, yeah, so this doesn't actually add any items to the modifier. It calls another function that does that. I'll show you that in a moment. Okay, so the first thing we do is we say tree.getRoot. Tree is the syntax tree. This is what we parsed. And I don't know if it does that live all in one shot or if it starts doing it as we call and make requests against it. It could stream through these and just get them piece by piece. I don't honestly know. I will look into that and see if we have performance gains one way or another depending on how we use it, because we can stream through the entire thing at once. We're not looking item by item really. Okay. Now, for this, we get all the nodes and tokens. That's a function I created. It is... I wonder if does this work, or is that just page down? It's page down. Figures. Let's see. I have parse code 2. I'm looking for get all. Let's do function F12. Yay! Okay, I'm here. So it's just an IEnumerable. We return yield the node. We take whatever node we're passed in and we give it back right away. And then we go for each of its children, the node's children, And then we say, hey, get all the nodes and tokens from that child and yield return them. And remember, the first thing this function does when we call it is pass back itself and then all of its children. So this continues on and on until all of the children have been passed back and we get one long list of code. All right. So up here, this loop is going through every single item. That could be syntax, that could be key, that could be, I'm losing all the words here. That could be variables, that could be fields, that could be public or private or static, whatever. All right, so for every one of those, they do have some things in common. Any one of these nodes or tokens has a location. So we get its location, and this tells us its span. Its span gives us the ending position and the starting position. So we can tell it started at character 0 and it went on to character 5 using. All right, so we have using, and then we tell it, okay, get us the modifier, but whatever, we'll get onto that in a second. After we have the span of being able to identify its position, next thing we're going to do is get its kind. Its kind is a little bit difficult. That one is, let me show you this. This is the source code for Roslyn. Roslyn is open source, which is pretty awesome. I had gone through this huge headache of trying to parse out or section out just this code, and then ended up figuring out that I could get NuGet working in Unity, and then was able to extract this packet, the correct package, directly into Unity, and then just had to fix the way that it worked because it's Unity and not Visual Studio. All right. Anyway, but as you can see, the different kinds of things there are in here, there's over 500 different kinds. So it was going to take a while to parse and get through, so I didn't bother with that. But anyway, I'm getting the kind, what type it is, and I'm getting a color for that, which is another function I created. And all this does is it checks, hey, do we have something in our kind colors dictionary for that? Oh, we don't? Okay, great. Well, we'll add one, and it just creates a random color. And I have a function here called minimum, so it never drops below a certain brightness level. Nothing all that impressive. Okay, so it adds it if it didn't exist, and then it returns that color. So let's go back, back, up there, yay. So we get the color. We have the color we're going to format this with. Next, we take the span starting position. We use getMod to get the modifier for it. I'll show you that in a second. So we have a modifier, and we set it for the starting position. And we set its insert to add the color equals hashtag, and then I do colorUtility.html string RGBA color. And that's a nice one just to get the hexadecimal color values for the color. And it also has two HTML string RGB, which you could use as well. I usually just default to including the alpha codes with it as well. And of course the closing bracket. Next, we do the exact same thing at the end. There's one difference though. In this one, I'm doing a plus equals, which means it'll take whatever's already there and append this color tag to it. The ending one will add the color tag, the closing color tag, and then add whatever was already there. The reason being is because what if there was already a color tag at that modifier position? If there was a color tag and we added it to the end, then we would effectively just close that color tag instantly, the instant we started it, and that'd be useless. Or at least it would leave it up to the whatever's going to be parsing it to view those tags and colors and formats to make its own decision as to how to handle that process. And I don't want to do that. I just want it to close out properly. Okay, so this getMod function, I said that I would tell you how we get the modifier. It's a very simple function. We just say return from the list where the index equals a specific index, and we pass in this list we create. Now, if it doesn't, I then call, okay, give us first or. First or doesn't actually exist in system.link. So I built the extension for it. You can find stuff that's very similar online. I ended up using one that was pretty similar to this, except for the fact that they used variables. You created the type it was going to use, except why create the type every time we're going to get the modifier when some of the times it's not going to be needed. So I just I'm using a constructor instead, which basically says return the first item it finds, and if it doesn't have an item in the array that matches this setup, then execute this code and return whatever it passes back. So in this case, we create a new modifier here. We set the index to the index that we got. We set the insert to a blank string, and then we add it to the list to make sure we keep track of it and can use it again later. And then finally, we return m. M is the modifier. All right, so we have the modifier. We're able to set the colors. We've got the index. Now we need to sort this index because some of the items will be out of order. For instance, the first one that shows up in here is actually code. What was it? It's the starting and the ending. Well, whatever the case, the starting and the ending of one spot might be wrapping around an entire block of code or even the entire file, while inside of it, it's going to have children that are isolating and identifying specific items inside of that block of code. All right, so over here we sort it to basically make sure we just get all of that in order, and then we create a string builder because we're going to assemble a new string with a lot of potential items added to it. All right, so we go through every one of these modifiers, remember sorted, and then we tell it, okay, append a substring of that source from the previous index, which is 0 to begin with, to whatever the index of the modifier is minus the previous index. So in this case, we need length. So in the first case it runs, it should typically return 0 unless someone has some empty space at the beginning of the class, and I don't even know what we'll do then. Might have some special kind to identify and call out empty space or white space. Who knows? All right, so we're grabbing the first string and we add it to the string builder, and then we take whatever the modifier wanted to insert. And then we set the previous index to whatever the modifier's index was, and then we move on and loop this over and over again until it's added every piece of code to this. All of the source code gets back into it. And finally, we tell sb2string to put it all back together and fill UI source.text. And this is our rich text element. And that is effectively how the entire source code runs for this. And because of the fact at the beginning of my code, I told it to clear the actual color list that it produced for this in the first place, then when I'm in here and I press space, it clears the code every time, and then when it comes back and asks for, hey, what's the color code for a variable, or what's the color code for a quote mark or a plus symbol, it always comes back with the same thing. And I get my Christmas light effect. All right, so that's how I did this. If you have any feedback, any suggestions or ideas, any ways to improve it, well, aside from the fact that I'm going to work on some performance stuff, but if you have experience and have already improved the performance of something similar to this, that I'd love to hear what your take on this is. If you could reply in the YouTube or to my blog. All right, or to the Codavore blog. All right, so anyway, we got all this stuff in there. I hope it's useful for you. Thanks.